Okay, hi everybody. So last time we met, I was talking about the neuroglia of the CNS, and that was your astrocytes, your oligodendrocytes, your microglia, and your appendable cells. So today we're going to be talking about the neuroglia of the PNS, the peripheral nervous system. And there's basically only two of these, well, so that's a good thing. And they are, first of all, you have something called satellite cells. All right, and so your satellite cells are like astrocytes in the central nervous system. And so what satellite cells do is they basically hold neurons in place. They're going to hold my neurons in place. All right, and then they may do some tissue repair to nerve cells if they get damaged. So I'm just going to put the repair neurons. Okay, and that's basically it for the satellite cells. Again, they're only in the PNS. If it was in the CNS, that's going to be your astrocytes. So let's talk about the more important one, and that's going to be Schwann cells. So I'm going to erase this real quick. Okay, let's talk about Schwann cells. Okay, so if you recall, when we were talking about the central nervous system, we said that in the central nervous system, you had some cells that make myelin called oligodendrocytes. In this case, in the peripheral nervous system, the cells that make myelin are called Schwann cells. So let's take a look at myelin real fast. And let's say this is a nerve that I have in the peripheral nervous system. And here's my axon, and then it's going to come off and go something like this. So this is my axon. Now right now this would be an unmyelinated axon. But let's put some myelin on there. All right, here's some myelin. And here's some myelin. And here's some myelin. And here's some myelin. Okay, so we call this myelin. Now myelin is made up of basically lipids and proteins, and we call the covering around the an axon a sheath. So the myelin sheath covers the axon. The purpose of this is to increase the speed of an impulse, and we'll get to that in just a minute. So now let's take a look, and if you notice between the myelin, we have openings here, and these openings are going to be called the nodes of Ranvier. Okay, so these are going to be my nodes of Ranvier. Okay? And that's those right there. Now, the area that has the myelin that's between the nodes can also be called internodes. Okay, so internodes are going to contain the myelin. Internodes, okay? So now, this right here. And of course, then this here, and over here, and over there. So those are all my internodes. That's where the myelin is. If we don't have myelin on a nerve, what will happen is the impulse has to travel all the way down the nerve. If we do have myelin now, it can actually skip over this and carry on, okay? And so it can move a lot faster. For the most part, if it's an unmyelinated fiber, the impulse travels at about 2 miles per hour. If it's myelinated, it can travel about 40 to 300 miles per hour. You're going to see myelinated axons for things that you have to interpret very quickly, such as eyesight. You're going to see it for hearing, balance, things such as that will carry that. These here are more like, my guess would be if you have to go to the bathroom, that's not a big hurry. Hunger, things like that. Might be on unmyelinated nerves. Pain would be up in here. So anyways, let's go on and take a look at these. So what I'm going to do now is imagine we are looking at this nerve, this axon, that looks like this. So we're looking at it from the lateral view or from the side. And what I'm going to do now is I'm going to pull that out and turn it this way. So now we're looking at it this way. So we want to look at this nerve, and now we're going to look at it this way. Okay? Or imagine I took the whole thing out and went like this. And now you're looking down the nerve. Okay? So imagine that we cut this part right here. And let's take a look at it. So here's what would happen, is I cut that, and I have my axon, okay? There's my axon. Now, around that, if you notice, we have our myelin. So I'm gonna draw my myelin right like this, and I'll just color this in real fast. Okay, and there's my myelin. Okay, so let me write myelin. Okay, now on the myelin inside, we're starting to put together our Schwann cell. So what I'm going to draw now is I'm going to draw the nucleus to my Schwann cell. So there's the nucleus. Okay, there's my nucleus. And then what I'm going to do is I'm going to draw the outside of this Schwann cell, and we get something called the outer portion of my Schwann cell, the outer layer of the Schwann cell, is called the Neuroglia. Now, really quick, lemma is like another name for a membrane, like the cell membrane. So I have my Neuroglia, neuromembrane, okay? When we get to the muscular system, we're going to have sarcolemma. But that's basically my membrane. And then I'm just going to have the inside of my cell. Okay? So this is the inside of my Schwann cell here. Okay, and then that's just the inside. You can call it the cytoplasm. I'd have other organelles and things such as that in there. So there's my nucleus, there's my axon, there's my myelin, okay? And this is my Schwann cell. Now, what about unmyelinated nerve fibers? They're also going to have a Schwann cell too. So let's take a look at them. And if we come over here, and this is what I'm going to do, is I'm going to draw a bunch of little dots right here. Now let's put one down here, and go there, and go there, and go there, okay? So now, what I'm going to do is, if you notice, I had the neurolemma here was in purple. So now I'm going to use, oh, before I do that, what are these dots? So for the most part, these dots are going to be axons. All right? So we have an axon. Now, I put, what, 6 here? It doesn't matter how many you put. It could be more than 6, it may be less than 6. But here's the thing, is this is my okay, so this is now is still my neurolemma. Okay, so I still have my neurolemma on here. All right, so I still have my Schwann cell membrane. This is still going to be a Schwann cell. Let's draw my nucleus in the middle. All right, so I still have the nucleus in the middle of this. All right, and then I'm going to have my cytoplasm and my other types of other organelles. So that's just going to be the inside here. Okay, so this Schwann cell here, as you can see, holds more than one axon. And just to clarify, so this is unmyelinated fibers. Right? This is going to be unmyelinated. It's still my Schwann cell. Okay? And over here I have my myelinated. So let me write this up here. This is myelinated. Okay, so there's my myelinated. So once again, I have my myelinated Schwann cell. My unmyelinated Schwann cell is over here. Unmyelinated is going to have more axons in it. Myelinated is only going to have one axon, right? So now, here's the other thing about this, is for the most part, if you remember when we talked about oligodendrocytes, we said oligodendrocytes can reach out to different cells and different axons and basically make myelin, even in different parts of the same axon. It doesn't work that way with Schwann cells. With Schwann cells, each individual internode would have to have its own Schwann cell. So I would have a Schwann cell here. Right? SC stands for Schwann cell. Here's another Schwann cell. So each Schwann cell only does one segment of a nerve. Whereas oligodendrocytes, I could have an oligodendrocyte that's providing all this if this was the CNS. And also on another nerve, it could be providing all the myelin. It could be providing all the myelin on even another nerve. Whereas here, if you notice, we have to have a Schwann cell for each area that's in there. Okay, so that's basically it for the neuroglia of the the PNS. That's it for the neuroglia of the PNS. And like we said, it can travel a lot faster if it's on myelin than it does if it's unmyelinated. I hope you enjoyed the video.